This presentation is made possible in part by Missouri Department of Agriculture, the Environmental Protection Agency, and University of Missouri Extension. The goal of this program is to improve water quality through education and the proper use of pesticides, and through the identification of vulnerable areas in the environment. We will provide a definition of watersheds and potentially vulnerable watershed areas, and examine the criteria used to identify them. We'll review the use of pesticides in potentially vulnerable watersheds and the best management practices to protect water quality. We'll discuss the potential for off-target movement of pesticides through surface and groundwater and through spray drift, as well as other problem areas. And of course, we'll consider the significance of regulations in the effort to protect water quality. In developing best management practices for your farming operation, it's necessary to understand what a watershed is. A watershed is the area of land that drains to a particular point along a stream, a lake, or other bodies of water. As you consider how water might flow across a landscape, it becomes clear that determining the boundaries for watersheds can be a challenge. Watersheds or basin drainage areas play a significant part in the management of an area with the protection of water quality in mind. In the year 1803, President Thomas Jefferson used watersheds as a means of determining boundaries.
When we looked at the Louisiana Purchase, we didn't have what was called the Continental Divide at that time, so what they did was define the watershed as the boundary for the Louisiana Purchase. All the land where the water falls and runs to the Mississippi River, to what we now call the Continental Divide, is part of the Louisiana Purchase.
Watersheds are as varied as the landscape and include basins, subwatersheds, or subbasins.
We are fortunate in some ways to live in the single largest watershed in the continental United States. That's the Mississippi River Basin. This goes all the way from the Appalachian Mountains all the way to the Rocky Mountains. Contains more than 1 million square miles. Now within the Mississippi River Basin, we then have 6 major watershed areas that we look at. Where we're at here in Missouri, we live in the Missouri River Basin. Now, within that larger watershed, and we divide watersheds in what we call hydrologic unit areas, and we give them a number. The smaller that number, the larger the watershed. In the state of Missouri, we have 66 8-digit hydrologic units, or what we call HUCs, H-U-Cs. You have one big number, which says this is the bigger area, and then we add more numbers to specify a much smaller address or area that we're looking at.
Serious efforts to protect water quality and the environment require that pesticides be used in adherence to the directions on the product label. According to the Federal Insecticide, Fungicide, and Rodenticide Act, or FIFRA, the label is the law. Remember, the label is designed for normal or average conditions. Keep in mind that actual conditions in the real world may not be described on the label. In such circumstances, there is an increased potential for runoff and leaching.
There's often been the misconception that if I apply according to the label rate, I'm going to protect the environment. The label rates are designed, and the rates that are there are designed for your soil type and designed for weed control. The company that makes that chemical designed that rate to maximize the chance that you're going to get weed control, not protect the environment. So a label rate like atrazine has some other specific requirements. So you have to pay attention to some of these other things that are on the label for setback requirements, but also consider some of the other management practices, especially if you're on one of these high runoff potential soils. Just following the label is not enough, is the bottom line.
Various criteria are used to estimate how vulnerable a watershed may be to pesticide contamination. These may limit the effectiveness of a pesticide label to protect human and environmental health. For example, the natural features of a watershed, and the activities that occur there can impact its vulnerability to pesticide contamination. Hydrology and soils are important factors in the movement of pesticides within the watershed. They affect the potential for pesticides to move from the application area to creeks, streams, lakes, rivers, and groundwater. The Center for Applied Research and Environmental Systems website is an excellent source of information on watersheds. Every 2 years, the Missouri Department of Natural Resources identifies those bodies of water in the state considered to be impaired and lists them in the Missouri 303D list of impaired waters.
So as we have more and more data on different water bodies, we start identifying those that don't meet the criteria that it's been set for, whether it's for drinking, whether it's for fishing, whether it's for whole body contact. So every 2 years they develop a new 303D list that has to be approved by the Environmental Protection Agency. And for each state, we have one of those lists.
The particular geology of a region, along with the physical properties of a watershed, can help identify areas with the potential for runoff or leaching problems.
Missouri has a large amount of karst geology, or fractured limestone. One of the things that makes this so important to the state of Missouri is that allows a lot of our water, surface water, to get into those cracks and move down into the lower groundwater aquifers very, very quickly. Those are the things that feed our streams in many cases. It causes a lot of the beautiful springs that we have in the state of Missouri. And as that water runs through that karst, and many times it goes ahead and starts dissolving that rock. So it creates sinkholes, it can create caves. Missouri's official nickname is the cave state. We have over 5,000 registered caves in this state, a lot of it because of that underlying karst topography that we have. One of the problems we have with that is it can move a lot of contaminants from the surface down through that karst because it moves so quickly, it doesn't get much treatment, and then it comes out somewhere else. The time frame that the water is within the soil, within the rock, all helps to determine how pure it's going to be or how much it's going to be cleaned by the natural environment.
The landscape doesn't always reveal underlying areas such as sinkholes or high claypan soils, conditions that can have a significant impact on the effectiveness of various farming practices.
Yeah, one of the things that we've developed over the years, soil scientists and soil water conservationists, have been this concept of no-till, where you don't till the soil at all, you leave the maximum amount of crop residue on the surface, and that was designed to control soil erosion, which is a major problem. It's just that it doesn't work the same on all soils. In some soils, if you use no-till for a long period of time, you get better infiltration of rainwater and less runoff, but on these high runoff potential claypan soils, we actually see the opposite. We control the erosion, but we actually have more runoff loss. The volume of runoff is greater under no-till. It doesn't soak into the soil as well. And if your chemicals are sitting there on the top of the soil and easily washed off because you haven't mixed them into the soil, then that's why no-till doesn't work well on our claypan soils.
One of the big areas we get to talking about, we talk a lot about the soil and the importance of the soil when we look at water quality and the ability to either hold water or to allow water to run off. When we look at sediment, pesticide, nutrient runoff, a lot of that we talk about deals with the soil. Sometimes in different parts of the state, what's even more important is what's that underlying parent material.
Soils with a claypan in the top meter increase the risk of water runoff. The shallower the claypan, the greater the runoff risk. Sandy soils, on the other hand, can allow pollutants to leach into groundwater at a rate faster than label directions recommend. Depth to groundwater is an important criterion affecting watershed vulnerability. In summary, consider the significance of watersheds in the management of an area with the protection of water quality in mind. Remember how a watershed is defined and the characteristics that identify it as vulnerable. Every 2 years, the Missouri Department of Natural Resources identifies those bodies of water in the state considered to be impaired and lists them in the Missouri 303D list of impaired waters. The particular geology of a region, along with the physical properties of a watershed, can help identify areas with the potential for runoff or leaching problems. Depth to groundwater, hydrology, and soil type are important factors in the movement of pesticides within the watershed. When it comes to pesticides, the label is the law. However, keep in mind the pesticide label is designed for normal or average conditions, which may differ from your real-world circumstances. These differences can impact the effectiveness of best management practices in pesticide application and should be considered prior to any pesticide purchase and application. For more information, contact these resources.